So now we're ready to start section 8.3, inverse trigonometric functions. And we're going to start by defining the inverse sine function. So let's start with a graph of the sine function, which we're very familiar with. Takes values between -1 and 1. And I've sketched more than one period here. I have pi over 2, pi, 3 pi over 2, 2 pi, etc. labeled. We're familiar with the fundamental period from 0 to 2 pi. And so as is, this function is not one-to-one. It does not satisfy the horizontal line test. Horizontal lines can cross the graph many times. And so, as is, this function does not have an inverse function. And so you might say, well, good, let's just forget about it, but that's not what we do. What we are going to do is we're going to restrict the domain of the sine function to an interval of x values over which the function is one-to-one. There are a lot of possible ways we could do this, but there is just one traditional way to proceed, and we're going to follow tradition. It's something everyone's agreed to do. And so I'm going to draw the restricted domain graph down here at the bottom. And this is how the traditional form got selected. I think whoever came up with this decided they wanted to keep the 0, 0 point on the graph, which is like the easiest, simplest point on the graph of sine. And then they wanted to take as much of the graph of sine going in each direction from 0, 0 as possible. So if I go back up to our sine wave here, it's kind of like we want to extend that way and that way as far as we can in both directions and still have a one-to-one function. Well, we can extend all the way down here to the point at -pi over 2, and we can extend all the way to the point here at pi over 2. But if I try to go further than pi over 2, we hit this max point, and when we cross beyond, we start falling again. So we're going to lose one-to-oneness. If I go any bit beyond pi over 2, I'll no longer be taking a piece of the graph over which we are one-to-one. Same thing if I back up beyond -pi over 2. If I go further beyond, I would have a portion of the graph where we're no longer one-to-one. So the largest piece of the graph that I can take containing 0, 0 on which we still have a one-to-one function is going to be the portion I outlined here in red, and I'm going to just draw that right here. Goes from this point to that point. And so drawn by itself, it just looks like a little bit of a wiggle. I think it's really, really helpful to remember that we're choosing a portion of the full sine wave, but only from -pi over 2 to pi over 2. So we restrict the domain of f of x equals sine x to the interval of x values from -pi over 2 to +pi over 2. I put square brackets around because we're including the x value -pi over 2 and +pi over 2. The range is still negative 1 to 1 in square brackets. So the nice thing about this portion of the graph is, or one nice thing, is that we use all possible y coordinates between negative 1 and 1, including negative 1 and 1. So now we have a one-to-one function. And so we can define f inverse, the inverse function. Now let's think about how we would do that. I drew, back the camera up again a little bit. I drew this same graph on a larger sheet of paper here, a separate sheet of paper. Notice the interval from negative pi over 2 to pi over 2, the y interval negative 1 to 1. So this is the portion of the sine wave that we chose with the restriction, right? The black is the restricted portion. To get the inverse, I want to change the input to the output, output to the input. I want to interchange the roles of x and y. So I want to interchange the two axes. To do that, I have to flip the picture over, and the values that were on the x-axis, the horizontal axis, the negative pi over 2, pi over 2, become values on the vertical, the y-axis now. And the negative 1 to 1 y-axis becomes a negative 1 to 1 horizontal. That's going to be our x-axis. So actually, just by flipping that picture over, interchanging the two axes now, I can see what the graph of the inverse sine is going to be. And we're going to actually draw this together on another sheet here. So let's focus in again. So right here is, I just recopied the restricted sine function. And so below, I'm going to start working on f inverse of x, which we're going to denote as sine inverse of x. So you want to read that as sine inverse of x. Don't say sine to the negative 1. It does not mean 1 over sine. It means inverse function. We've interchanged the roles of x and y. And I want to draw a graph. So I'm going to horizontal axis, vertical. So my values on the horizontal here, the restricted sine, become values on the vertical. So I'm going to have a pi over 2, and I'm going to have a negative pi over 2. My vertical axis becomes horizontal, so I'm going to have a negative 1 and a positive 1. 0, 0, when I interchange the coordinates, is still 0, 0. That's on my graph. Pi over 2, 1, when I interchange the coordinates, interchange the roles of x and y, I get 1 comma pi over 2. That's this point right here. When I interchange the coordinates of negative pi over 2, negative 1, I get a point with coordinates negative 1, comma, negative pi over 2. And the shape is a little bit subtle. That's why I went back to my graph where I drew the sine, I just flipped it over to see what the shape of the curve would be in the inverse. It's going to do something kind of like so. Okay. So this is the sine inverse. The domain of the inverse function is actually the same as the range of the sine function. Its domain is square bracket -1 to 1. Its range is the same as the restricted domain that we used to define it from the restricted domain of sine. So that will be -pi/2, pi/2. That just reflects the fact that we've interchanged the roles of x and y. And you have to know how to draw this graph. And I have a handout that's posted in Canvas that kind of sums up the details and also draws a connection between the original sine and this inverse sine. Sine inverse of x is also written, there's another very common notation for this, ARCSIN, arc sine of x. That means exactly the same thing. In fact, if you use Desmos, you'll see they use the arc sine, ARCSIN notation. I kind of like that because you avoid this -1 that looks like an exponent that is not an exponent. Sine inverse of x does not mean 1 over sine x. Unfortunately, it sure looks like it might, but it doesn't. It means inverse function. And I have just one more idea I want to put down here. When we work with this notation, sine inverse of A equals B, we're going to interpret it often by rewriting that statement using the regular sine function. So the input for the inverse becomes the output for sine. The output for the inverse corresponds to the input of the sine function. So that means sine of B, so B becomes the input of sine, and the input here becomes the output of sine. And there's this added condition we're going to have to keep in mind, that this angle came from that restricted domain. So the B value is always going to be between pi/2, -pi/2, and +pi/2, possibly one of the endpoints. And I think I'm going to stop this video here with our definition of inverse sine. And in the next video, we'll do some calculations. We'll start doing some problems.